All right. In our previous class, we learned how to configure BGP, the basic BGP. We
Yeah.
are going to continue this again, this chapter again from the beginning. A quick
Okay.
walkthrough. We say router BGP and then the autonomous system number. And you cannot configure more than one autonomous system in a router. Only one instance of BGP on a single router. So if you need another BGP, you need to delete the older one. And then the neighbor statement allows us to define the IP address, a reachable IP address of the neighbor. And the remote AS command allows us to provide the autonomous system number in which the neighbor is in. If the neighbor is not an IBGP, then this autonomous system that we specify here will be different from the autonomous system that we have specified here. Say, for example, if I say 100, if the neighbor autonomous system is 150, which means they are ebgp neighbors. This particular neighbor is an ebgp to this router. If it is same, then it is internal neighbor. If it is different, then it is external. That's what we also see here. So it is the neighbor statement that determines whether the neighbor is an IBGP neighbor or ebgp neighbor. Here is an example. Router A has got two neighbors. One is router B, the other one is router C. Router B's address is 10.2.2.2. If you see here 10.2.2.2, neighbor 10.2.2.2, the autonomous system of the local is matching with the autonomous system of the neighbor. That shows that 10.2.2.2 is an IBGP neighbor for this router A. Unlike 192.168.1.1, which has got different autonomous system, which means 192.168.1.1 is an ebgp neighbor. It's an ebgp neighbor. Router B, if you notice, there is only one ibgp neighbor. So the autonomous system of router B and the autonomous system of the neighbor is same. This is ibgp. See, ibgp need not to be directly connected. The reason is when B sends the negotiation packets to A, the outgoing TTL will be 255. So IBGP neighbors can be anywhere within 245 hops, whereas ebgp neighbors need to be directly connected. The reason is when a packet is sent, when BGP packet is sent, the time to leave of the packet will be just only one. Just only one. So ebgp neighbors need to be directly connected because the outgoing TTL is only one. If I want to temporarily shut down a neighbor, I need to remove the neighbor. I can simply say neighbor address and shut down. And then when I want to bring the neighbor back, I need to just cancel this shutdown command by putting no in front of that same configuration which I use for shutting down. So this is the best way. Instead of we removing the neighbor completely, we just shut down because we are temporarily shutting down the neighbor. We discussed this command Whenever BGP send a packet, the source address is going to be the outgoing interface address, and the destination address is going to be the address that is defined in the neighbor statement. For example, in our previous diagram, when router B send a packet, what will be the source address? The outgoing interface address, which is 10.2.2.2. What will be the destination address? The address that is mentioned here in the neighbor statement, 10.1.1.2. Now, when this packet reaches router A will check whether the source address matches with the neighbor statement. Yes, it is matching. If it matches, then packet is accepted. If not, the packet will be ignored. That's what exactly we are seeing here. When a BGP packet is received for a new BGP session, the source address of the packet is compared with the list of neighbor statement. If match found, the relationship is established. If no match is found, the packet is ignored. So what we need to do is we need to make sure the source address matches with the address that is mentioned in the neighbor statement of the other router. Very important. The source address needs to match with the address of the neighbor statement. In this case, we have redundant paths to reach each router. B can be reached from C via A as well as D. Likewise, D can be reached from A via B as well as C. Whenever we have redundant path, it is recommended to use a loopback interface of the neighbor as the address to form neighborship under the neighbor statement. It means that router A's neighbor address will be 4.4.4.4 to form neighbor with D. Likewise, router D's neighbor address will be 1.1.1.1 if D wants to form neighbor with A. Advantage is, if any one of this path is available, the neighborship will continue, will not break. But when I use a physical interface address, for example, I go to router A and say neighbor is 10.2.2.4. When I say 10.2.2.4, if this link goes down, the neighborship breaks. But when I have a loopback interface, even if this link goes down, no problem, the loopback can be reached via this way. So the neighborship continues. Forming a neighbor with loopback is good, but the problem is, we saw in the previous page, the source address of the packet is compared with the neighbor statement. We are saying on router A 4444 as a neighbor. And on router D, we are saying 111 as a neighbor. Now, when router D send a packet, it will use any one of the exit interface. That's what we saw here. The outbound interface address is defined as a source. So, for example, if the source address is this, and when packet approaches router A will check whether the source address matches with the neighbor statement. It doesn't match. So the neighbor is going to be ignored. If the match is not found, the packet will be ignored. The neighborship will not happen. So what is the solution? The solution is, instead of sourcing with the outbound interface, which is the default. Instead of sourcing with the outbound interface, you need to source it with the loopback interface. The command to do that is update source. Neighbor IP address and the interface of the loopback. Here we see B and C wants to form neighbor because you got a redundant path, you want to use loopback. So on router B you say neighbor as 33333, and router C you say 222 as a neighbor. The neighbor address is 2222. And without fail, we also say update source loopback 0, so that when router B send the packet out, it will source it with loopback 0, which is 22222, whenever it speaks to 33333. Likewise, when C speaks to 2222, we are saying use your loopback 0, which means you should use 3.3.3.3 when you speak. But make sure this 2222 is pinging 33333 and vice versa. For that, what we have done here is we are running the protocol EIGRP to provide reachability between these two. This is where we stopped. So I told you earlier that between ebgp, if the neighbor is not directly connected, the neighborship won't come up. For example, see this autonomous system. A and B, even though they are directly physically connected, we are not using the directly connected IP address. We are using the loopback address of the neighbor. Even though B is directly connected, the address that we have specified to represent B, it's not directly connected. The network that we have specified about B is not directly connected. I want to ask you a question. Try to answer. You have router A.
Yep.
In router A, in the routing table, which all network will have C? In router A, 192, 168, 1.17 will have C because it is directly connected, correct?
Yep.
Likewise, 192.168 or 1.33 will also be seen as directly connected.
Yep.
So actually it is 32, okay? Here 32 and this is 16. Network. This is the first IP, that's why it is 17. 28, mask is 28.
Yep.
In the routing table, what do you see? You see IP address or you see the network? In the routing table, will you see an IP address or you will see a network of the IP?
The
The
network
network
IP.
of the IP. The network of this IP is this. That is subnetting. The network of this IP is this.
Subnetting, yeah.
Okay. And then I'll also have connected saying 2.2.2.2 via loopback 0. Fine. Now on this router B, connected 192.168.1.16/28, connected 192.168.1.32/28, and also connected 1.1.1.1/32 via loop. This is how the routing table will be. Am I right?
Yep.
Okay. Now, router B has got two static routes. See here. To reach 2.2.2.2, one static route says you need to go to 192.168.1.17. Another route says you need to go to 192.168.1.33. Am I right?
Yep.
Now, my question is, this neighbor, who is this
Yes.
2222? Is it A or B?
This neighbor is A.
A. Now, do you see neighbor address, neighbor's network as connected or something else?
Is connected.
Hello. On router B's routing table,
No, no. Oh no. In routers B routing table. No, I don't see. No.
instead of
It's
what do
in
you
the
see? Instead you see 2 is connected
static
via
static
this.
routing.
It says connected via this, not directly connected. Correct?
Yes. Correct. Yeah. Correct. Yeah.
That is the secret. You see, if you don't mention this command,
Yeah.
if you don't mention this command, I'm telling you
So
something very important. If you don't mention this command, router
it doesn't
B,
work.
router B will not send not even a tiny packet. Router B will
Yes.
not send even a tiny packet. Why? Router B will check whether neighbor is shown as connected. C. Is it shown as C? No.
No.
Because it is not shown as C, it will not send any packet. You know why? Because the norm says the neighbor should be directly connected. If the
Yeah.
neighbor is directly connected, you would have seen C, not
Yes.
S. Because the norm says ebgp need to be directly connected,
Yeah.
because the norm says ebgp need to be directly connected,
Says definitely if it is not in the routing table,
it is
routing
there in
table
the
it will.
routing table, but it is not shown as connected directly. As a
Oh,
result,
okay. It will not.
it will
It
not
will drop the
send any
packet.
packet.
Yeah.
So when you say ebgp multi-hop 2, what really happens is you are breaking the rule. You are telling BGP that neighbor need not to be directly connected. If it is 1, then the rule is applicable. But because you said ebgp multi-hop 2, which means the neighbor need not to be directly connected.
Yep.
See, whether the neighbor is 2 hop away or 20 hop away, that doesn't matter. Here, what you are actually
Yes.
achieving here, you are indirectly telling that the neighbor is not directly connected.
Yep.
By saying ebgp multi-hop 2, you are changing the default policy of sending TTL1 as outgoing. You are changing it into 2. Usually, it sends the packet with TTL of 1, the outgoing packet, the outgoing, the TTL value of the outgoing TTL value of every packet will be 1 by default. But when you say 2, two things happens. One, you break that rule which says neighbor need to be directly connected. Secondly, the TTL gets incremented to 2. The outgoing TTL becomes 2. Now I want to do this two things and show you. First, I want to show you the IBGP using loopback. Secondly, I want to show you ebgp using loopback. Shall we do the lab?
Okay. Yep.
So we got two autonomous system here, but there is no BGP or OSPF. Just we see these things in the whiteboard. OSPF area 0 to provide reachability between R1 and R3. We have a plan of configuring BGP on R1 and R3 only, not on R2. That is to show that IBGP neighbors need not to be directly connected. And then between R3 and R4, we'll form neighbor using the physical interface initially. That's to show that the ebgp neighbor TTL value, outgoing TTL of all ebgp is 1. And the outgoing TTL of all IBGP is, what's the IBGP TTL value, outgoing TTL value?
IGB outgoing TTL value IBGP
Hmm?
1.
No.
Sorry, it's 2 for EBG. Sorry, 1
255.
for. Sorry, 255. Yes, sorry, 255.
The
And
outgoing
1 for
TTL value of IBGP is 255.
255.
The outgoing TTL of EBGP is 1. This is what
1.
I want to show you first. First thing that I want to show you is the TTL. Okay, let's begin.
Yeah.
Right now, if I check show IP route, there is no route to reach R3. I want to form neighbor with R3, but there is no IP reachability. For that, I'm going to enable OSPF. I'll go under interface, range, loopback 0, F00. Am I right? I'm going to this two interface and I'm going to say IP OSPF1 area 0. So in both the interface, I have enabled OSPF. Do you agree with this?
Yep.
Show IP OSPF interface brief. You can see here OSPF is running on this too. Show IP protocol now. You see OSPF. Now on router 2, if I type show IP protocol, there is no protocol, but I'm going to say now interface range loopback 0, F00 -1. I'm under how many interface? 3 interface. One loopback and 2 physical, F00 and F01. And I say IP OSPF1 area 0. And you will see now router 2 and router 1 forming OSPF neighbor. See, the neighbor has come. Now likewise on R3, interface range loopback 0, F00. I'm not going to run OSPF on F01. You know why?
Yeah, this is EBGP other side.
No. I'm not going to run OSPF on F01. Why? Because
Oh, okay.
it's
So,
WAN facing
yeah.
interface.
Yeah. It's a
OSPF is
WAN
an
facility.
IGP protocol. It should be within the autonomous system. The F01 is an outside autonomous system.
Yeah, outside.
Okay. So I'm not going to run OSPF on F01. I'm going to just do it on F00 or loopback 0, IP OSPF. Now, if you see, we'll be able to ping between R3 and R1 loopback. Let me ping 1.1.1.1 with the source 3.3.3. Let me ping. We need to give some time because we just configured. Okay, now it's pinging. All right. We got the reachability between R1 and R3. Likewise, if I ping 123.34.34.4, Who is this? 123.34.34.4.
Being from R3.
Who is this
So, we,
123.34.34.4?
so is it the router? Oh, I'm sorry. It's a R4.
R. So it is
Sorry.
directly connected. You see, I'm trying to ping. It's pinging.
Yeah.
Now, first thing is I want to form IBGP between R3 and R1. I'm not using loopback. I'm not going to use loopback. I'm going to use the normal physical interface. Before that, I want to show the Wireshark. Now in the capture, you see OSPF hello packets every 5 seconds, 10 seconds, every 10 seconds. OSPF hello is going every 10 seconds.
10 seconds.
Okay, now what I'm going to do is I'll go to router 3 and say router BGP 1000. What is the neighbor address?
123.34.
No, I said you will do IBGP first.
Oh, I'm sorry. It's a 10.12.0.1.
Yeah, 10.12.0.1. Remote AS is same 1000.
Yep.
Now, as soon as I hit enter, what will happen, Router 3 will use its exit interface. What is the exit interface address of router 3? Yeah.
10.23.0.0.3.
Using that as a source and using this neighbor address as the destination, it will start sending TCP three-way handshake packet. I want to show you that. You see, Wireshark at the background. All right, I hit enter. You see, as soon as I hit enter, you'll see TCP packets going from router 3. It will come now. You see, this is TCP packet
Yep.
going from the outgoing interface. 10.12.0.1, right? Sorry, 10.23.0.3. That's the one initiating router 3, and it is going to router 1. How do you know it's a BGP packet? Is it written BGP anywhere?
No, it doesn't. It didn't written
It is
anywhere.
shown TCP, but how I call this BGP packet? Because the port number is
It is for
179.
yeah. This is yeah. See port.
It's a BGP packet. It is BGP packet because the port number 179 is given to BGP. But will the three-way handshake be successful? No. Why? Because router 1 is still not configured. You understand what I'm saying?
Yes.
Wait, let me show you what is happening here. See, this is the TCP packet. Let me stop the capture and show you in detail. Are you ready for something learning something new? Are you ready?
Yes.
Okay, focus
Yes.
then. You see, router 3 is sending the first packet. Where have you configured BGP? Only on router 3.
Yep.
We have not configured BGP on
On
router 1.
R1.
So router 3 only will send the packet. What will be the source address? 10.23.03. Isn't it?
Yes. Yes.
That is what you see here. 10.23.03. That's the source. And the destination is the address that we mentioned in the neighbor statement. And when I open that packet, I see that the TTL value, when it is received, the TTL value is 254. When it is sent, what is the TTL value then? See, if R1 is receiving
Two.
254, then
Yep.
when R3 is sending, it will be 255. When it received on R2, it is 255. When R2 sends, it is 254.
4.
So this proves that the TTL is 255. Yeah. Secondly,
Yep.
if you open the TCP, it is sending a sequence number and it is expecting an acknowledgement for this sequence number, the last sequence number. It is expecting an acknowledgement. But the problem is the other router 1 is not configured. See, this is coming from router 1 going to
Yep.
router 3. That will not provide any sequence number. It provides an acknowledgement. See, 132. What will be the acknowledgement? 133. So you see 133 as an acknowledgement, but there is no fresh SYN packet.
Yeah, I
This is
mean, no
only a
sequence number
reset.
from R1.
Yeah, from R1 there is only reset packet coming, not SYN plus ACT. From R3 to a
Okay.
SYN packet, the response should be SYN plus ACT. Instead, you get reset ACT. The reason is we have
Right.
not configured what? BGP. We
BGP.
have not configured BGP. So I'm going to restart the Wireshark again, and I'll go to R1 and finish configuring to R1. Right now we go to R1 and I say router BGP 1000, neighbor 10.23.0.3, remote is 1000. As soon as I say this, the three-way handshake, which was resetting. See, the red color is resetting, which is bad. The red color is resetting. If you open, it says very clearly that it's a reset packet, RST. But when I hit enter, you will see all three-way handshake successful. I'm waiting. Finish. Let me stop. Please pay attention now. If I go top, as soon as I hit enter, you see, router 3 is sending what? SYN packet. Router 1 is
Yes.
responding with SYN ACK, not reset ACK. SYN ACK.
Yep.
And then there was an ACK from router 3, which is three-way handshake. After three-way handshake, BGP's open messages, and this is what called as BGP's open message. How do I know this is an open message? It should be written somewhere here also. See open message.
Open message. Yeah.
BGP's open message. Let me pull the information here.
And the keep alive message, another one.
Wait. All right. So open message is sent
Okay.
from 3 to 1.
Yeah. Yeah.
And the other open message from 1 to 3 is also sent. And keep alive will be sent every 60 seconds. And then update is sent between these two routers. And then update. Only when there is an error, notification will be sent. So these are all the packets that is sent. And now if you go and see, there should be neighbor. Look at this, neighbor.
Yep.
And if you notice the TTL, when it comes from R1, the TTL is 255, you see? 255.
Yes.
I'm sniffing near R1. So when R1 sends the packet, I can see the TTL, exact TTL. Yeah?
So R1 is 255 and R3 is 254, right?
No, you didn't understand that portion. Wait, let me explain you.
I mean,
Wait, let me explain you, sir, please. When this is sending, it is sending with 255, right?
correct, yeah.
This will decrement 1 and it will send us 254. When R3 receives, it will receive as 254. Now,
Yeah,
when R3 sends a packet, what will be the TTL? 255.
when R3 will send to, yeah, when R3 send it will 255.
And this will decrement 1, and when this sends to R1, it will be 254. Okay, this is how it is 254.
Okay.
Now, I would like to show you, even in the command line, the TTL values that are used. Go to R1 and check. R1, the command to check the TTL values and all is show IP BGP neighbor. Okay, show IP
Yeah.
BGP neighbor. And what do you see here? On the top, you see router 3 is the neighbor. The router ID of router 3 is 3333. And the router 3 belongs to same autonomous system. The neighbor is established. Okay, there is only one neighbor and it is active. So far, one open message is sent and received. One update is sent and received. 6 keep alive sent, 5 keep alive received. Totally 8 packets sent and 7 packets received. And if you go down here, you are going to see TTL, the next page. Boom. You see? The outgoing TTL is what?
255.
Yeah. For IBGP, the outgoing TTL is 255. And what is the incoming TTL value? 0.
0.
Is it not written there? Yeah, minimum incoming TTL is 0, meaning the neighbor can be from any number of hop. I'll accept
Yeah.
neighbor even if he is having TTL of 0.
Okay.
The outgoing is 255. The incoming is 0. This is IBGP. Are you ready for EBGP now?
Yes.
Alright, let's go to EBGP now. On R3, I'm going to say I got another neighbor who is 1, 2, 3, 34, 34, 4. Remote AS of that neighbor is 1001. This is fine? Yeah? Now let me
Yeah.
stop the debug here, sorry, the Wireshark here, and I'll start here. I'll start here one. Huh? I'm capturing between EBGP routers. Now, I have not said enter. I'm going to say enter. Look at this. You will see a SYN packet sent, again the reset will happen because R4 is not yet configured. Wait for this, it will come now. Look at this. What is happening here? SYN and then a reset. Do you see? Reset. The three-way handshake is not happening.
Yep.
Now I want you to see the TTL. What is the TTL value? What is the TTL value? 1.
1. Yeah.
You see? Not this one. Packet going from 3 to 4. You see the TTL value is 1.
1.
BGP's TTL value for EBG, this is BGP packet. How do I know? The port number is 179.
179.
So BGP sends with a TTL of 1. Why it is not forming neighbor? Because the router 4 is not configured yet. So let us go to router 4 and configure now. Oh, sorry, it's not one. Router BGP, what is the number? 1001. Neighbor is 123.34.34.3. Remote AS is 111001. Yeah. As soon as I hit enter, you'll see in the Wireshark three-way handshake successful. Wait, it's going to happen now. Okay, done. Let us see now. I'll stop the Wireshark. Now you go up. You see, um, SYN was sent. SYN ACK was received. You see, from 3 to 4, SYN was sent. 4 to 3,
Yeah.
SYN ACK was received. 3 to 4, acknowledgement was sent. And then open message was sent. And then notification message was sent. And then what? Keep alive. All sent. Open message. Keep alive. Fine. So it's happening well. I should see. I guessed it. Because too many read, no, I understood something is going wrong. Somewhere I have given a wrong autonomous system number. Aha. Look at this. This is the wrong one. What is the autonomous system number
Okay.
of router 3?
It should be a different one.
1000.
1000, yeah.
But what I have given is 1001. So I'm going to remove this and then I'm going to put 1000. Now go back to the Wireshark. Oh, again I need to capture. Anyway, BGP has come up now. You see? The neighbor has come up. Now let's verify the TTL. Show IP BGP neighbor. What is the TTL you see here?
So, what is the
What is the
TTL?
outgoing TTL you see?
This one.
Because of this, one, you cannot
Yeah,
form neighbor with
ebgp.
loopback to loopback.
Yeah.
You cannot form neighbor with loopback to loopback. Right? So